So today we're going to cover how to find area of regular polygons. But before we begin to do that, we need to learn about different parts of a regular polygon. So all of our polygons are going to be inscribed, or they'll be the center of a circumscribed circle. So our polygon will be inscribed in a circle. So the center is the center of the circumscribed circle. The radius is the radius of the circumscribed circle. It's also going to be the distance from the center to the vertex. We're also going to learn about central angles within our polygons. And our central angles are going to be formed by two radii, which will be drawn to two consecutive vertices. And then the apothem, which will be the perpendicular distance from the center of the polygon to a side. And I'm going to talk about the picture here momentarily. All right, so let's zoom in here. So this is a hexagon that is inscribed in my circle. I have center point P. I have some radii here, and they're the red lines. So the radii are PM and PN. These would be radii. My apothem is the blue line. It's PQ. The apothem goes from center to the side of the polygon. Notice it doesn't go all the way to the circle, whereas the radii do. So the radius is always going to be longer than the apothem. The central angle is formed by two radii. So my central angle would be this angle right here, MPN or NPN. So it's always formed by two radii. Next, we're going to back to my picture here. I could draw in all of the radii. And remember, a central angle, see the definition? It's formed by two radii drawn to consecutive vertices. So this is a central angle, so is this, here, here, and here. How to calculate the measure of a central angle. And the measure of the central angle can be found by taking 360 and dividing it by the number of sides. So in the case of my hexagon in the previous slide, you need to know that a hexagon has 6 sides. So a hexagon is 6 sides. So you're going to take 360 and divide it by 6. And each one of the central angles are going to have a measure of 60 degrees. Once you add up all of those central angles, it should add to be 360 degrees. So for example, if I draw another hexagon here, and I draw in my radii, each one of these central angles here has a measure of 60 degrees. If you go, let me add a page here, and I'm gonna review special right triangles with you. So let's review special right triangles, because when we have a triangle, a hexagon, or a square, we're going to be using our special right triangles. So if you recall, there were 2 of them. We had the 45-45 special right triangle, and we also had the 30-60-90 right triangle. Now, when we learn this, I used the letter A. So just so we don't get confused with the apothem being set equal to the letter A, I'm going to use the variable x when I'm describing these legs and these sides of the triangle. So in the 45-45, we know that the 2 legs, or the 2 sides that form the right angle, are going to be x. Then the side across from the 90 degrees, or the hypotenuse, is whatever x is with square root 2. This is a review. Then for the 30, 60, 90, the side across from 30, I'm going to call that x. The side across from 60 is going to be x square root 3. And then across from 90 is 2x. When we did this before, I used the letter A, but I don't want to get confused with A being the apothem. So I'm going to call, when I'm solving these, I'm going to call it the variable x. So now that we've reviewed the special right triangles, we're going to see how we're going to use that when we're finding area of polygons. So here it says, let's identify the center. So my center is point P. Notice that's the name of my circle. I have a radius, which is here, and I have another radii over here. So you could either name PX or PY. You could also draw in your own. You could draw PZ and PW. These are all radii. For the apothem, remember that's the perpendicular distance from the center to the side of your polygon. It does not go all the way to the circle. So my apothem here would be PQ. And a central angle, remember that is formed by two radii. So a central angle would be this angle here, and you could call it XPY. You could also go the other way, YPX. You also have more central angles here, here, and here. However, in the original diagram, if you only use what was already formed, it's the XPY or the YPX. Now we're going to find the measure of some of the angles in our figure. So let me go ahead and make this a little simpler. Let me erase some of this so it's not so complicated. So here are my radii. And remember, it forms a central angle. Remember, to find the measure of the central angle, you take 360 and you divide it by the number of sides. A square has 4 sides. So this tells me that each central angle is going to have a measure of 90 degrees. So that's my XPY, which is this first one. Once you draw in your apothem, it bisects that central angle. So that tells me that each piece here is 45 degrees. So XPQ, which is the angle I just labeled right here, oops, right here, is 45. And if you realize that once you drew your apothem, and I'll draw it upside down here, if this angle is 45 and this is 90, then this one down here is 45. We just talked about the 45, 45, 90. Again, another way you could figure out what that angle is, the PXQ, is it's going to be 45. The 3 angles of a triangle add up to be 180. Subtract the right angle, subtract the 45 you found at the top, leaving you 45 for the bottom. Or remember that when it's a right triangle, the 2 acute angles are complements. So to just subtract it from 90. So this is how you can identify a center, a radii, an apothem, and a central angle, and to find the measures of those angles. Let's look at it this way. So if I were to draw a square, and if I draw in, that sort of looks like a rectangle, but if I were to draw, let's put a point here. Remember, the diagonals of a square are perpendicular. So these central angles here that have all been formed around here are 90 degrees. But the formula that you do is 360 divided by the number of sides. And that gives you 90 for each central angle. Okay, so next, these are the formulas to find the area of a regular n-gon with side length s and the apothem. So it's going to be, the area is 1/2 apothem times perimeter, or you can memorize it as area equals 1/2 apothem times the number of sides times the side length. Realize that this P, which represents perimeter, is just the number of sides times the side length. So remember, to calculate perimeter, you're adding up all the sides or taking the number of sides and multiplying it by how long the side is. These are all regular figures, so all side lengths are going to be the same size. The second formula here, it tells you that the A represents the apothem, the N represents the number of sides, and S represents the length of each side. All right, so if you already have the perimeter calculated, use this first formula. If you do not have the perimeter calculated, but you know the apothem, the number of sides, and the side length, then you use the second formula. They're both solving and getting the same answer. It's just a different form. Let's try and put this and do an example. So we're going to be finding the perimeter and the area of each figure. So the first one wants me to find the area of a regular hexagon with an apothem of 6. The second example wants me to find a regular octagon with a side of 5 and apothem of 3. Let me do example B first because it's easier. Okay, notice I'm going to calculate, it wants me to find both perimeter and area. So in order to find the perimeter, and what I would do first before you start these problems, we need to find what A equals, which is the apothem, what the number of sides are in our figure, and the side length. So my apothem was given to me on part B. It equals 3. I'm going to get the value of n from knowing what the word octagon means. An octagon means that it has 8 sides, and it told me my side length was 5. Now that I have these 3 numbers, I can just plug it straight into the formula. So to find perimeter, I'm going to take my number of sides, and I'm going to multiply it by the side length. So the number of sides is 8. My side length is 5. So the perimeter of my octagon is going to be 40. The formula for area, since I've already just calculated the perimeter, and let me just show you both ways. Apothem times perimeter, or I could take 1/2 apothem times number of sides times side length. I can do it either way. So 1/2, my apothem is 3. My perimeter I just calculated is 40. And now I'm going to multiply 1/2 times 3 times 40, and I get 60 units squared.
That's the area?
That's the area of the polygon.
Wait, so
Notice this NS? That's what P is. It's just another way to write the formula. So if I do it this way, my apothem is 3, my number of sides is 8, and my side length is 5. So even if I multiply it this way, 8 times 5, 40, times 3, 120, divide by 2, I still get 60 units squared. So it doesn't matter which formula you use, they're both going to give you the correct answer for area. So if they're not asking you to find perimeter, use the second one and just find ANS. But let's say the problem already started out by giving you the perimeter and the apothem. You just multiply those two and divide by 2. Now, the hexagon, we've got to draw a figure and use and find a special right triangle. Notice in example A, all they gave us was apothem. Remember, I told you to start by writing down what A equals, what N equals, and what S equals. I don't know what S equals, so I'm going to draw a picture and create a special right triangle. So let's try this one. I'm going to draw a hexagon. 1, 2, 3, 4, 5, 6. So here is my hexagon. All of these sides, even though it doesn't look like it, are supposed to be the same length. This is a regular hexagon. I could draw my circle around it, but I really don't need it. Here is my center. I'm going to draw in 2 radii that go to consecutive vertices. I'm going to calculate the measure of my central angle. Remember, to find the measure of the central angle, you're going to take 360 and divide it by the number of sides. This gives me a central angle measure of 60 degrees. That's the tippy top there. Now, I'm going to take out that triangle that I just formed with the 2 radii. So I'm going to enlarge it here. So I'm going to pull out the triangle. I'm also going to draw in my apothem. Remember, your apothem goes from the center to the side of the polygon. And I know this is a little crooked, but let me see if I can draw it better. We get the idea. Okay, so the apothem forms a right angle. Remember, my central angle was 60 degrees. My apothem bisects that central angle and makes it 30 and 30. So now I'm going to work with just part of this. So up here is 30. Down here will be 60. And over here I have the right angle. Now, remember, the sides of your 30, 60, 90, the side across from 30 is x. The side across from the 60 is x square root 3. And then your radii is 2x. Now, what was given to me was the apothem length. My apothem is 6. Notice this 6 is the a root 3. I need to solve, or x root 3. I need to solve for x. So I'm going to solve x square root 3 equals 6. I'm going to divide by the square root of 3. X is equal to 6 over the square root of 3. I need to rationalize, multiply top and bottom by square root 3. 6 square root 3 over 3 simplifies to 2 square root 3. That's what x equals. Remember, x is down here, and it's only part of my triangle. So over here, I also have 2 square root 3. So to get the length of the side, I'm going to add 2 square root 3 plus 2 square root 3, and the length of the side of my hexagon is 4 square root 3. So for here, I now have the side length. It's 4 square root 3. I now can calculate the perimeter. Remember, perimeter is number of sides times the side length. The number of sides in a hexagon is 6. I just calculated S to be 4 square root 3. So the perimeter of my hexagon is 24 square root 3 units. To find the area of this hexagon, I'm either going to use the formula area equals 1/2 apothem times perimeter. Because I have my perimeter calculated, that's what I can do here. So 1/2, remember your apothem was given to you, it was 6, and the perimeter is 24 square root 3. I'm now going to multiply these three things. Now, if you want to take half of one of them, like I could take half of 6 and say half of 6, change this to a 3, and now multiply 24 times 3, and I get 72 square root 3 units squared. You can also find area by multiplying 1/2 apothem times number of sides times side length. It's going to give you exactly the same answer, but if you think about it logically, we've already done the NS when we did the perimeter. But let's do it this way. 1/2 apothem times number of sides times side length, which is going to be 4 square root 3. So here, if I multiply, again, I could take half of the 6, and then I could multiply 24 times 3 again, 72 square root 3 units squared. The hardest part is going to be finding the missing pieces. Once you have A, N, S, it's a matter of plugging it into the formula. But if you're still struggling with right triangles, you need to practice that skill. This time I have an equilateral triangle. So let me draw a triangle here. So we know all sides are the same because it's equilateral. These are all regular figures. It doesn't matter. So if I draw my center here, so again, you could put the circle around. Draw your radii in. Notice this creates 3 central angles. To find the measure of the central angle, you take 360, divide it by the number of sides, and each central angle is going to be 120 degrees. I'm now going to pull out one of the triangles. So the one here formed on the bottom, it's got 120 degrees here up at the top, because the triangle I've just pulled out is this one here, because I need to find the side length. Notice they gave me the length of the apothem. So again, my apothem I'm going to draw in green. Remember, it's the perpendicular distance straight down. Remember that apothem bisects that angle. So now the tippy top here, when I've split it in half, is now 60, and the 30's down here. Remember, they told me the apothem is 8. So let's just work with one of the sides of the triangle. This is 8, my 60's here, 30, and the right angle. Remember, the side across from 30 is x. Side across from 60 is x square root 3. And this would be 2x. So I already know what x is. So all I have to do is put 8 square root 3. But remember, this is only for this piece. So this is 8 root 3. and so is this. So to find the full length of the side of the triangle, I'm going to add 8 plus 8 and get 16 square root 3. So now my apothem is 8, the number of sides in a triangle is 3, and I just found the side length to be 16 square root 3. Now to find the perimeter, yes? So perimeter is equal to the number of sides times the side length. A triangle has 3 sides, and I just found the side length to be 16 square root 3. So my perimeter is going to be 16 times 3, and it's 48 square root 3, and these are units. For the area, I'm going to be using the formula 1/2 apothem times perimeter, because I just calculated the perimeter. My apothem was 8. It was given to me at the beginning. And my perimeter is now 48 square root 3. Now, you can either choose to do 8 times 48 and then divide that answer by 2, or divide one of the numbers by 2, and then you've got a smaller thing to work with. So 8 divided by 2, I'm going to change this to a 4. And now 48 times 4 gives me 192 square root 3 units squared. And that would be the area of that triangle with an apothem of 8. Let's do another hexagon. So again, let me draw one in here. Put 6 dots here. Make my sides. It's supposed to be regular. Draw in 2 radii. So let's pull this out. If you recall, the central angle is going to be 360 divided by 60. So I know this central angle up at the top is 60. But as soon as I draw down the apothem, it splits that 60 into 30 and 30. And then this would be 60 down here. I'm only going to work with one side of my triangle to find my missing sides. So if I pull this over, my apothem, and then my radii, and then this one's 30, 60. So across from 30 is x root 3, and this is 2x. Notice this time they gave me the side length. So my side length is already 12, so this is 6, and this is 6, or together it's 12. So the apothem this time is what I'm solving for. And if my side length, if half of my side length is 6, then I know my apothem is going to be 6 root 3. So now my apothem is 6 square root 3. The number of sides in a hexagon is 6, and my side length was given to me, and it's 12. When you have a regular hexagon, the side length and the radius length is going to be the same. All right, so now perimeter, number of sides times side length, 6 times 12, and my perimeter is 72. For the area, 1/2 apothem times perimeter, so 1/2 square root 6 times square root 3 times 72. I can simplify, make this a 3, and now 72 times 3 is 216 square root 3. These are units squared. Again, the perimeter is just units. Okay, so this one is a square with a diagonal of 10. So let me just get a square in here. And then I'll draw my diagonal. And this diagonal has a length of 10. Now, remember we're going to draw in the central angle. And remember the central angle is created by 2 radii. So I'm going to take 360, divide it by the number of sides, and I can see that my central angle here is 90 degrees. So now what I'm going to do is pull this triangle out so I can work with it as a special right triangle. So once I drop down my apothem here, it forms a right angle, and notice that 90 degrees up at the top is going to be bisected. So now this turns into a 45-45 degree right triangle. So 45, 45, the right angle. So let me make this green. This is my apothem. And then here is my radius. And this is part of my side length. So if you recall, they told us that the diagonal was 10. So this tells me that this piece here is 5 and 5. So if I put a 5 here for my hypotenuse, remember in the 45-45, this 5 is equal to whatever x is with root 2. So these are my 2 legs here. So I need to solve this. X root 2 equals 5. Divide both sides by the square root of 2. X is equal to 5 over square root 2. Rationalize. X equals 5 times square root 2 over 2. So that is what this little piece is here and this piece over here. So when I add them to get the side of my square, the side of my square is going to be 10 square root 2. So if I add this, 10 square root 2 over 2, I can simplify this. So the side of my square is 5 square root 2. Now, my apothem was x. So my apothem here is going to be what I just solved for x, which was 5 square root 2 over 2. So let me go ahead and write all these variables over here on the side. So the number of sides, it's a square, it's a 4. My apothem is 5 square root 2 over 2. And my side length is just 5 square root 2. I now need to calculate the perimeter. The perimeter can be found by multiplying the number of sides times how long each side is. So it's 4 sides, and each side length is 5 square root 2. So then I'll multiply the 4 times 5, and my perimeter of the square is 20 square root 2 units. So for the area, remember you're doing 1/2 apothem times perimeter. My apothem, again, is 5 square root 2 over 2, and my perimeter is 20 times square root 2. So I'm going to go ahead and simplify. I can simplify the 2's and make the 20. I can simplify that diagonally and make that become a 5. So then now I'm going to multiply what's left. So I multiply the 2 outside numbers, 5 and 5. That'll give me 25. And then I multiply the 2 radicals, square root 2 times square root 2, just makes it come out of the radical. So my area of this square is 50 units squared. And once you find the side length, if you remember back from elementary and middle school, area of a square is just side times side, or side squared. So once I found out what the length of my side was, which was 5 square root 2, I could have just squared that. And that becomes 5 squared is 25. Square root 2 just becomes a 2. And I could have also gotten the 50 that way. I didn't need to do the whole apothem times perimeter divide by 2. So when we have a pentagon, or my last example is going to be an octagon, if they don't give you the ANS, then you're going to have to use trig to solve it, because we're not going to be able to turn it into a special right triangle. So let me go ahead and draw a pentagon here. So again, notice it says regular, so that tells me all sides are equal. So here is my pentagon. And if I put my center point here, now I could draw the circle around it. And then I can draw in my radii. I need to calculate the measure of the central angle. Remember, to find the measure of the central angle, you're going to take 360 and you're going to divide it by the number of sides. So 360 divided by 5 is 72. So the measure of my central angle is 72 degrees. So I'm going to go ahead and pull out this triangle I just created. I'm also going to drop down my apothem. So let me pull this little red triangle out. I'll make the side length of the pentagon black. The apothem will be in green. And remember, the apothem is going to bisect that angle up at the top. So if the entire angle at the top is 72, once I divide it by 2 and bisect it, it becomes 36. And then to find the other angle down at the bottom, I could do 90 minus 36. I really don't need to figure this out. I can get away with just using the 36, but this gives me 54. I'm going to base all of my answers to find the apothem and the side length based off the 36. You could also do it based off the 54. So if I go ahead and just make half of the triangle of that main piece that I pulled out. Again, I'm going to answer all of my, or I'm going to do all my questions or my proportions based off of the 36. So I'm going to label my sides based off the 36. So the side that's opposite the 36 is here. The side that's adjacent is going to be my apothem. And then the red is the hypotenuse. Notice they told me that the radius length was 8, which is my hypotenuse over here. So now I'm going to set up my trig to figure out what opposite and adjacent are. So if I want to find opposite, using opposite and hypotenuse, this is going to be sine. So sine of 36 degrees is equal to opposite, and I'll call that x, over hypotenuse. And now I solve this. Remember, when the variable's in the top, to solve this, you multiply. So I'm going to do on my calculator 8 times the sine of 36. So when you're doing these, make sure your calculator is in degrees. So on my calculator, what I'm keying in is sine, and then hit in 36, and then times 8. And we're going to round this to the tenths place, so it's going to be 4.7. That's going to be the length of this, which is also the length of this. Now to find my apothem, or my adjacent, I'm still going to use the 36, but this time it's adjacent and hypotenuse. So I'm going to do cosine of 36 is equal to adjacent, and I could call this A because it's my apothem, over 8. Multiply both sides by 8. Once you do cosine 36, multiply that by 8, you're going to get 6.5. We're going to round it so it ends up being 6.47. So I'm going to round it to 6.5. So that's the length of my apothem. Now that I know all of the values, so let's go ahead and write down what we know. Okay, so n, number of sides, is going to be 5. My side length, remember I'm going to add 4.7 plus 4.7, or times it by 2, and I get 9.4. So my side length is 9.4, and my apothem is 6.5. For perimeter, number of sides times the side length. So 5 times 9.4, and I get 47 units. Now I'm going to find the area, and the formula I'm using is 1/2 apothem times perimeter. So 1/2, the apothem is 6.5, and the perimeter is 47. So I'll multiply that. 47 times 6.5, and then times 1/2 or divide by 2. And the area is going to be 152.75. If we round it to the tenths place, 152.8 units squared. Okay, here it wants us to find the area of a regular octagon with side lengths of 10. Now, for perimeter, all we need to do is, we already know that the number of sides in an octagon is 8. For the side length, it's going to be 10. So I can already do perimeter. It's n times s. So 8 times 10, and I can already see my perimeter is 80 units. However, to find the area, I need to find the apothem. So if I draw an octagon here, just put 8 dots around it, connect it. Just remember, all of these sides need to be spaced equally because it's a regular octagon. So I'll go ahead and put my center point in here. I'm going to make my central angle by drawing in 2 radii. And now I'll pull that triangle out. So if I pull it out, drop down my apothem, I need to calculate the measure of that central angle. Remember, to find the measure of the central angle, you take 360 and we divide that by 8. So 360 divided by 8 gives me 45. So the angle up here at the top, my central angle, is 45. But remember, once we draw in the apothem, it's going to bisect that 45. So it's going to make the angle up here at the top 22.5. We divide it by 2. And again, they gave us a side length of 10. So each one of these sides here are 10. Remember, the 10 is for this whole thing. So when I bisect it, the side I'm using here for my trig is a 5, not a 10. Now, in relation to the 22.5, the 5 is opposite. This is going to be my hypotenuse, and this is going to be my apothem. Now, I don't need to find the hypotenuse. All I need is the apothem. So this is going to be adjacent. So I'm going to be doing tangent, because I'm looking for adjacent and I have opposite. So I'm going to do tangent of 22.5 is equal to opposite over adjacent, which is also my hypotenuse. My apothem. All right, so now when your variable, let me do it in black so it shows up a little bit better. When your variable is in the denominator, remember we need to divide to solve. But if you want to see the math behind it, we're going to multiply both sides by a to get it out of the bottom. So then it becomes a times tangent of 22.5 equals 5. To solve for a, which is our apothem, I'm dividing 5 by the tangent of 22.5. So 5 divided by tangent 22.5, and you get 12.07. I'm going to round that to the tenths place, and I'm going to make it 12.1. So now to find the area of the octagon, I'm using the formula 1/2 apothem times perimeter, 1/2 12.1 times the perimeter, which was 80. And then now I can multiply this using my calculator. I could take half of 80 and now just do 40 times 12.1. And I get 484 units squared.